All right, let's go ahead and get started today. Thanks again for being here today. We've got Gabe with AutoHot with us today. He'll be doing a navigating ICC, the IECC Energy Code compliance for demand controlled hot water recirc systems. So we've had him on before, had a great webinar. Some of it was highly technical, which I liked because a lot of stuff I learned that was new that I didn't know. So recirc systems are part of the code. But Gabe, thanks for being here, and I'm going to go through just our quick housekeeping real quick. So as always, this is going to be recorded. It will be uploaded to our YouTube channel probably within 72 hours after all of this. We'll just edit that and upload it to our YouTube channel. It is eligible for the IECC or ICC continuing education credits. You do have to be on for about 75% of the time, three-quarters of the time to get credit for that. As always, I'll be monitoring the chat, and also we'll have Juliana is also here with us. She'll help monitor the chat. We have any specific technical questions, she can help with that. So those that are new to Spear, and if you're not familiar with who we are one of 6 RIOs, energy efficiency organizations. We are a member-based nonprofit organization, 501(c). What we do is advocate for adoption and enforcement of the energy code throughout Texas and Oklahoma. So again, Gabe, thanks for being here, and are welcome to share. I will turn off my sharing, and you guys can take over.
Perfect. Thank you. Well, thank you again, Randy. Thank you to Spear for giving us the opportunity. And thank you all for joining us this beautiful Monday morning, afternoon, whatever the case is, wherever you are. Today, I'm going to talk about a topic that's near and dear to me. It's on-demand recirculation hot water systems. And I'm with a company called Innovative Manufacturing. We're based out of Los Angeles, California. And we're the maker of AutoHot. We're the leader in on-demand hot water recirculation technology. We make hot water control systems for residential and for commercial buildings that are geared for new construction or to retrofit existing buildings that have bad plumbing. And one of the hallmark of our systems is that they do meet the most current energy code requirements, whether it's IECC or California's Title 24. And so the problem that we're talking about today addresses the age-old issue of why are we waiting for hot water, right? Everyone has experienced this at some point, either in their own home or if they're out, on vacation or something. You turn on a faucet and you have to sit there and wait for a frustratingly long period of time for hot water to be delivered. And not only does this is this very inconvenient, but also ends up wasting a tremendous amount of water, as we'll see. So why are we waiting for hot water? Has nothing to do with the type of water heater you have. Doesn't matter if you have a tank or a tankless water heater. But here are some of the factors. Number one is over the preceding decades, our homes have slowly gotten bigger footprint on average. So the median U.S. home has gone from about 1,600 square feet to around 2,500 square feet. And so the average distance from where the water heater is to the farthest fixture, the end of the plumbing line, has more than doubled. Okay. The number of fixtures have doubled. Pipe diameter has increased by a magnitude of 2 to 3 times. And IATMO is working right now on trying to right size plumbing so that it's a better match for actual hot water demand. And then fixture flow rates have been reduced by 2 to 3 times. So you take all of these factors together, and now it takes us almost 20 times as long to get hot water in newly built homes than homes that were built, decades ago. And so this is really about structural waste, not so much about user waste, but structural waste, how the plumbing is designed. And this results in anywhere from about 3 to 10,000 gallons of water wasted annually per home. So that's where hot water recirculation systems come into play. And what is a recirculation system, you may ask? Well, it's a system where you install a pump that circulates hot water from the heating source and has that water delivered to the farthest end of the plumbing line, oftentimes by way of a recirculation loop. So you have this return line, and at the end of that return line, you have the pump. And so it decreases the time for hot water to come out of your tap. It also provides the convenience of fast hot water. And this is what really a lot of people are, getting recirculation systems. A lot of builders are putting in recirculation systems because just adds a whole lot of convenience. But at the same time, it's a huge water saver. Like I said, the Department of Energy estimates that a typical home can save up to 10,000 gallons of water by not having it run down the drain every time that you turn it on. And this is particularly of interest of builders and communities that are in the Southwest United States, where water is becoming more of an issue. I spent the last 20 years. I just moved back to Minnesota, ironically the land of 10,000 lakes. But the last 20 years, I was in Southern California, and we went through an unprecedented 10-year drought where it never rained, and everyone was conditioned to save water wherever you can. And this is just another water saving measure that you can implement into your buildings. But however, not all recirculation systems are created the same. And I like to use the analogy of an iceberg where you have the upfront cost of the pump and the system, but then there are these hidden operational costs that most users probably aren't aware of unless they're really paying attention. So what are these operational costs? Running a recirculation pump by itself is not inherently energy intensive. It's a small fractional horsepower pump, but you do have the electricity to run that pump, right? So if you're running the pump excessively, you are going to be consuming some kilowatt hours from that pump. There's also the non-energy uh, costs, the maintenance and repair. Hot water recirculation can be very damaging to a plumbing system if left uncontrolled. Pinhole leaks, scaling in the heat exchanger of a tankless water heater, worn out heat exchangers, all of these things contribute to operational costs. And then there's this one, heat losses through distribution. So what does this mean? It means that whenever you're running the pump and you're circulating hot water through your pipes and no one's actually using hot water, your water heater has to keep turning on to make up for all of these radiant heat losses in your plumbing. So these are the main operational costs to a recirculation system. But there's one of these three things in particular has by far the largest operational cost. I would ask for a show of hands or pick someone from the audience, but I'm just going to go ahead and tell you what the thing is that uses the most that is the largest operational cost. It is the heat losses in the pipes. So upwards of 90% of the operational costs of a recirculation system is from the heat loss in the pipes as a result of uncontrolled recirculation. So most pumps are running either 24/7 or some suboptimal type of control that has the pump running for hours and hours unnecessarily. So really the strategy is to control the pump, and then you control those energy losses, and now it's no longer the biggest energy hog in your house. So what are some types of recirculation pump controls? Well, the first one is no control, and sadly, most buildings or many buildings just plug the pump in and just leave it running all the time. And as I said before, not only is this the worst thing that you can do from a maintenance standpoint, but also from an energy standpoint as well. And then there's timers, and this is kind of like the most, I'd say, the most often used type of control for a recirculation system. You put a schedule on the pump. Let's have it run from 8 a.m. to 10 a.m. or 4 p.m. to 8 p.m., whatever you want to set it for. You have temperature controls that turn the pump off when the end of the line gets to a certain temperature. And then you have a certain combination of these two. And I'd say that's probably the most frequent type of control. Then you have some new type of controls that have hit the market recently. You might see some variable speed drive, which basically modulates the speed of the pump based on when people are using or not using hot water. But really, it doesn't turn the pump off at all. It just keeps the pump running just at different speeds. It's more of a strategy to reduce the electricity consumption of the pump, but doesn't really do much in way of reducing the distribution heat losses. We also see some new other types of pump controls that supposedly learn your habits and turn the pump on and off based on an algorithm that learns when you use hot water in your house. But these types of controls are basically glorified timers at best, and I'll explain why. If you think about when you use hot water in your own house, in your own home, oftentimes those events are very spontaneous and unpredictable, right? You can sort of predict when you take your shower in the morning or evening, but outside of that, it gets very spontaneous as to when we use hot water. So these smart controls really don't stand up to that variation in hot water events. Last but not least, there's demand controlled recirculation. And of all of these control strategies, only the on-demand system accurately matches the runtime of the pump to when hot water is being used. So it has the most amount of pump off time. You get all of the benefits of a recirculation system in terms of fast hot water, in terms of water savings, but you don't have any of the energy losses or the wear and tear associated with recirculation systems. So when do you not need to run the pump? Well, if you don't need hot water, you don't need to run the pump, right? So if you're at work, or if you're on vacation, or if you're sitting and watching a webinar, or maybe you are at home and you're watching TV or sleeping or doing something else, that pump does not need to run. Secondly, if there's already hot water in the line, the pump doesn't need to run, because once hot water is at the end of the plumbing terminal and it's just flowing out of your faucet, then the draw flow will move, the city pressure moves the hot water through your pipes. So it's really only during this transitional period when your hot water lines have cooled down and there's a demand for hot water. That's really the only time that the pump needs to run. And then it only needs to run for about 30 to 60 seconds before turning off. So that's the concept of a on-demand or demand-controlled recirculation system, is that it uses a sensor or a switch to turn the pump on, which is indicating demand for hot water. And this can come in different forms. It could be a manual switch, it can be a motion sensor, an occupancy sensor, could be a flow sensor, could be some type of a wireless device, could be voice activation. It could be something like, "Hey Siri, get me hot water." Anything that detects the presence or the demand for hot water within the occupancy. And then it uses a temperature sensor to tell the pump to turn off once hot water has reached the end of the plumbing line. And these systems will work with any type of water heater. It doesn't matter if it's a tank or a tankless or a heat pump water heater. On-demand works with all of them. Okay, so let's look at a kind of a typical recirculation loop configuration, and we'll go through the sequence of operation. So you have a little activator. Maybe it's inside of the kitchen and the bathrooms. Maybe you have it somewhere, maybe somewhere outside of those areas. But basically, number one is demand is sensed by the occupant, and then anytime the control senses that, it's going to check the temperature of the return line or the end of the plumbing line. We're after the last plumbing fixture. And then once the temperature is checked, if it's at or above its target temperature, the pump does not turn on. It stays off. So let's say somebody just used hot water's in the line, somebody else goes in there and pushes a button, pump does not turn on. And then the pump is only going to run until the temperature is satisfied. So as a result, the pump typically doesn't see more than about 10 to 15 minutes of runtime per day in total. And compare that with other control types that have the pump running for 4, 8, 12, or even 24 hours a day. So let's take a look at a comparison between an on-demand system versus a more conventional timer-based system. And again, the timer-based systems are basically just a schedule where you try to guess or predict when hot water is being used in the home. And oftentimes, because of our, changing schedules and changing habits of when we use hot water, sometimes that pump is going to be running when you don't need it to. And also sometimes the pump is not going to be running when you do need it to. Um, so timer-based pumps typically run anywhere from 4 to 12 hours per day. And then an on-demand system typically runs for only about 5 to 15 minutes of runtime per day. And again, it's not just from the energy standpoint, but it's also important to stress how damaging circulation flow can be to your plumbing system over time. So there's been a lot of research that's been done on the energy cost of recirculation systems, and here we see some data from Gary Klein, IATMO research presentation. This was some years ago, but they did some modeling, made some assumptions, and essentially, showing the amount of heat losses with a timer-based pump or a 24/7 pump versus an on-demand system. And there's a significant decrease in the amount of energy and cost, utility costs associated with these two types of systems. So if we take the national average of electricity and the national average of natural gas, we see that the incremental cost difference, it costs approximately $125 per year if the pump just runs 6 hours per day. And again, it could be much more than that. And it also depends on like the utilities that you use too. It could be higher cost. But with an on-demand system, typically it's, only about $5 a year in energy to operate. So even though on-demand systems typically have a little bit higher upfront cost, the savings is going to, the incremental cost difference is going to pay for itself within the first 1 or 2 years. And then not to mention the fact is that an on-demand system, because it's only running for very short periods of time, it's going to last you probably 3 to 5 times longer than a conventional recirculation system. Okay, so what are the benefits? Let me just recap the benefits of a demand-controlled pump. Is that reduction in total pump runtime. You get a 90+% reduction in distribution heat losses. You're going to get all the benefits of a conventional recirculation system. Fast hot water, thousands of gallons of water saved per year. It's going to meet your local energy code requirements, and I'll talk a little bit about IECC. The energy to operate the system is only about $5 or less. And as I said, you're going to get a much longer useful pump life, less system wear and tear. Another thing to note too is that the tankless water heaters, if you look at their warranties, they have, and it's basically for all tankless water heaters across the spectrum, whether it's, Rinnai, Navien, Noritz, Rheem, take your pick. They all have a warranty that says it's like either 10 years or 12,000 hours of the heat exchangers. So basically, any time that the tankless is seeing flow, it's tracking that runtime, and it's just chipping away at the warranty, the number of hours that you have on that warranty. So if you have a pump that's running for hours and hours out of the day, that's just depleting that warranty faster. So if you have a tankless water heater, really, the main strategy should be to control the pump as much as possible so that you extend the full useful life of that equipment. So IECC has over the years become more and more definitive about what type of controls that they want with recirculation. And here we see the residential code section 403.5. And what they say here is that controls for recirculating hot water system pumps shall start the pump based on the identification of a demand for hot water within the occupancy, and that the control shall turn the pump off when the recirculation loop is at the desired temperature. And then right after this, they even go into a little bit more specific about what demand recirculation systems mean. It means that the controls shall start the pump upon receiving a signal from the action of a user of a fixture or appliance sensing the presence of a user of a fixture or sensing the flow of hot water, temperate water to a fixture or appliance, and that the control shall limit the temperature of the water coming back to no greater than 104. So, in the past, the energy codes were a bit vague, to say the least. and it just said, the pump shall have a control to turn it off when it's convenient or something like that. Um, and they've really, over the past, I'd say, 3 or 4 iterations of IEC, they've become more and more specific about what that demand, quote unquote, demand means. Okay, so let's talk about the 4 main components of our auto hot on-demand system. Is that we have a pump, we have a controller, and that's kind of like the brain for the pump that tells the pump when to turn on and when to turn off. We have an activator, and then we have a temperature sensor. So the activator tells the pump to turn on, temperature sensor tells the pump to turn off. We strongly suggest or recommend that you size the pump based on the application, based on the size of the house. It's not always one size pump fits all applications, especially for an on-demand system. So, we suggest that homes that are up to about, I'd say about 3,500 square feet, you can go away with the smaller version pump. And then as you get bigger, to 4 or 5,000 plus homes, then you might want to consider sizing the pump up. This is just so that when the loop is being primed, when the pump starts activating, is that it still gets to the end of the plumbing terminal within a reasonable amount of time. And then you want to select your activators. So there's hardwire activators. They can come in the form of a rocker switch or a little push button activator. These are momentary contact, normally open switches. So think about like ringing a doorbell. So if you see this rocker switch, it's not like a light switch where you toggle it on and off. It's just momentary contact. So a lot of builders are running a low voltage wire from the point of use back to where the water heater is and where the recirculation pump is located. And so all of that equipment is going to be, the pump, the controls, that'll all be located back at the water heater typically. And then you'll just have like a point of use activator. There's also a motion sensor activation. So if you don't want to have a manual switch, you can have it so it's an occupancy sensor, and the pump only turns on when somebody walks in front of that motion sensor. But also keep in mind that because we have the temperature sensor, that if as long as hot water is in the line, even if people keep walking past the occupancy sensor, that doesn't mean that the pump's going to keep turning on. Once hot water is satisfied, the pump stays off. So if you are having guests at your house and they keep walking in and out of the bathroom, that doesn't mean that the pump's just going to keep turning on. It stays off. So there's different types of motion sensors. We have them. This is one variety. We have one that's kind of fits recessed into the wall. There's other types of switches. This is what we call our lighted indicator switch. So this lights up when hot water's ready and then turns off when your hot water line has cooled down. So if I walk into my kitchen and I see that the light is off and I know I'm going to be doing dishes, or I want to wash my hands, I see, okay, well, I'm going to have to wait. So I'm going to have to hit this switch. So once you hit the switch, it's going to start to blink, which means that the pump is running and hot water's on the way. And then within a few seconds, hot water reaches the end of the plumbing line, the pump turns off, and these lights will stay solidly lit until the lines cool down again. And then there's also wireless activation. This can be, a wireless button, a wireless motion sensor. There's various, apps with your phone that you can use. But these, I'd say the wireless buttons are one of the more popular accessories because of the range. They have about a range of about 1,000 feet in open air. So you could be anywhere in your house to activate the system. And you can have up to 10 wireless activators per controller. And then we've also just introduced a wireless version of the lighted indicator switch. So now builders can have that very nice, decorative rocker switch with the light indicator, but not have to run the low voltage wiring throughout the house. It just gets connected to AC power, just branch off of a local, switch, and it sends and receives the signal wirelessly. So that's saving builders a lot in those running the hardwired low voltage. Pairing activation, super easy. You just push a little button in the middle that puts it into pairing mode, and then you just hit the switch, hit the button, turn on the motion sensor, and then it just immediately pairs. And then you just repeat those steps for additional activators. What if you have a tankless water heater? I'm sure some of you that are familiar with the hot water world, a lot of tankless water heaters have introduced a version of their tankless that's got a built-in recirculation pump. Maybe some of you are familiar with this or seen this, but they've all got them. Navien was the first company to come out with it, and then they all kind of like copied Navien after that. So they all have this integrated recirculation pump, and they all have it kind of set up on they call it different things, Circ Logic, or I forget what all the other names for it, but they're basically, timer-based systems. Um, so let's say you have a tankless with one of these built-in pumps and you want to turn it into an on-demand system. No problem. We have this wireless receiver that connects very easy to any one of these tankless water heaters and will turn it instantly into an on-demand system where you can turn that pump and tankless on from anywhere in the house on demand using our wireless activators. The connections are very easy. In California, we have very strict energy code requirements for new construction and recirculation where they have to do on demand for everything. Timers are basically not allowed if you want to meet the prescriptive energy code requirement. So as a result, all of the tankless manufacturers have a little two-wire connection to put a little hardwired button or a hardwired switch. So all you have to do is just connect the receiver to that little terminal that's located on the circuit board, and then that turns it into an on-demand system. And depending on the tankless manufacturer, it might say like Title 24 push button switch or on demand or something like that. But usually we can help you identify where that terminal is. And then we have another product. Let's say you have an existing house that never put in a return line. So there's no recirculation line. And maybe the house is a few years old, and the homeowner just kind of has always suffered with long hot water wait times, but they want to have a circulation system. Maybe they don't want to spend the money to have a plumber come in and put in a whole new, repipe and put a return line in. We have an option that's an easy retrofit that can be incorporated into any building or home. And what we do, it's called the undersink crossover. We call it the USC for short. And essentially what this does is it uses your existing plumbing to create on-demand recirculation. So how does it work? You have the pump is located back at your water heater. Let me get my little laser pointer here. Okay, so your pump is going to be located back at your water heater, and that's where the controller is too. And then you want to identify the fixture that is the farthest off the line. So at the very end of the plumbing line, right? And most times this is like the master bathroom. So what we do here is we have this little, what we call the USC that cross connects your hot water line into your cold water line. And the way it works is anytime you want hot water, you push that button. And this little box here, this is a wireless temperature sensor. It's going to check your temperature. And if it sees that it's, not hot, then it sends that wireless signal to the pump to turn on. And now the pump is pulling hot water from your tank and moving through your pipes very fast. And then all the cold water that has been sitting in your hot water line is going to get pumped in through this bypass and into your cold water line. So this little cross connection allows circulation to occur in your plumbing. So now you have hot water that's moving. Now, when this temperature sensor sees a 6-degree rise in temperature, only 6. So if it's going from like 60 degrees to 66 degrees, that rise in temperature indicates that 115, 120 degree water that's from your tank is just a few seconds away. So then this sends a wireless signal back to the pump to turn off. So now the pump is shut off. It brought hot water all the way to the end, but you're not bleeding that hot water into your cold water line. And so now it's a very easy way to get on-demand recirculation without having to do any extra repiping or any, plumbing. You don't need to have power underneath your sink because this little wireless temperature sensor is battery operated. So you don't need to, the previous version of this type of equipment required that the pump be installed underneath the sink because the pump had to be told to turn off based on that 6 degree delta. But now that we have the pump back at the water heater, you no longer need the power underneath the sink. So this is all done by battery. You change the batteries about as frequently as you change your TV remote. And when it does start to go low, it'll start to be, indicating you just need to pull it off, change the batteries, and then put it back on the wall, and then you're good to go. So that's the Undersink crossover. Demand controlled recirculation does meet other building certifications, such as the Zero Energy Ready Homes program, LEED for Homes, and WaterSense. EPA's got these WaterSense guidelines for efficient hot water systems for homes. So it meets all of these criteria. We're also proud to say that we're going to be the featured recirculation system at the New American Home, the show home of the International Builder Show in 2026. So hope to see you guys at the Builder Show in Orlando next February. Let's talk about hot water recirculation configuration. So it's not just about the control of the pump that's important for a high performing hot water system. You also have to really follow some guidelines as far as how to run the plumbing and how to design the recirculation loop. So here are some things, generally speaking, that the recirculation line, or we call it the trunk line, should be no more than about 3/4 inch in diameter. And I know that IAPMO is considering like reducing this to maybe even 1/2 inch. But certainly no more than 3/4 inch. And then if you keep the branch lines, so the lines that are coming off of the main trunk line that go to each fixture, if you can keep these to about 1/2 inch and minimize the distance of the branch to about 15 feet, that's about 3 cups of water. So if you prime the loop with an on-demand system, then you're never going to wait for more than about 3 cups of water waiting for hot water at any fixture in the house. Obviously, all the trunk lines should be insulated. I think this is an energy code requirement. Even adding, just minimal R4 pipe insulation is considerably slows the cool down of those pipes. So it's very important that these be insulated. And then also try to avoid hard 90 elbows. And this is more kind of like a guideline for the plumbers to follow, but you want to use more sweeping radius elbows versus hard 90 elbows. That increases circulation, performance and reduces head loss. So when the loop is primed, you're not going to waste more than about 2 to 3 cups of water waiting for hot water at any fixture. And then on the return line, there's certain things that you need to incorporate too, such as like a check valves to prevent backflow, a bleeder valve or a hose bib to purge air out of the line, an isolation valve so that you can, maintain the pump and replace the pump or service it. So here's what it looks like on a typical recirculation loop for a house. Here we see this house has a couple of tankless water heaters. You have the cold water coming in here, feeding into these 2 tankless, and then here's your hot water supply going out to the house. And then here below it is the return line. So this completes the loop. Where it says T1 here, this is typically where we have our temperature sensor located. But in an ideal world, you'd want to put that temperature sensor right after the last fixture. So if you're able to run that temperature sensor just past the last fixture, that way you're never bringing any hot water back and you're making your system even that much more efficient. But just, from a practicality standpoint, most often plumbers are just putting that sensor, that temperature sensor right, upstream of the pump where it comes out of the wall. And then finally, you see here on the return line, you have that hose bib, and this is where you can bleed out the air in the line. Very important. And all of our systems and most other like Title 24 compliant on-demand systems have a built-in 5-minute timed lockout to prevent airlock. So in other words, if the pump is running and then in a 5 minutes goes by and it's not seeing that rise in temperature or that temperature lockout, then the pump is just going to automatically turn off. Because usually what that means is if the pump is running for 5 minutes and it doesn't see any change in temperature, it usually means that there's like air trapped in the line. So the pump might be spinning, but it's not actually moving any hot water. And when that happens, the pump will overheat because it needs to have that fluid traveling through it. It'll overheat and it'll just, die. And then you need to replace the pump. So we have that automatic timed lockout to prevent that airlock from damaging the pump. Here's another view of some tankless water heaters with external pumps versus internal pumps, and then of course we're starting to see on the West Coast here. We're starting to see a lot more heat pump water heaters. I don't know if that's something that you guys are seeing in the Texas market yet. I do know that like Texas would probably be a very favorable environment for heat pump water heaters, given like the nature of the climate. But I'm guessing that it's probably not hit your guys' market yet. But just know that heat pump water heaters are a completely different breed of water heater. And in
Yeah,
fact,
Gabe, I'll just jump in with that. We
yeah,
haven't seen a surge of those yet. I mean, the benefits, and as you just said for Texas, I mean, we got garages that get super hot around here, and if you've got a water heater in the garage, I mean, the byproduct of that is cooling the garage.
yeah,
But I think it's still just a apprehension of the costs. There's still some
yep.
incentives out there, tax incentives that make great choices. But no, we haven't seen a movement on that yet.
Okay. And I mean, I can't predict the future, but I would think that eventually, the price of heat pump water heaters are going to go down as they continue to scale up production, because in California now it's basically a requirement. And so all new construction in California is going heat pump water heaters. And we're starting to see kind of like the benefits, and also like kind of like the unintended consequences and some of the things that weren't anticipated. And so I want to talk, a little bit about recirculation as it relates to heat pump water heaters, just in the case that, maybe some builders do start to adopt heat pumps in Texas. But they are different. There's no combustion, right? It uses basically a compressor to extract the heat from the air, surrounding air, using the refrigeration process and to put it into the water. And it makes hot water very efficiently. When it works great, they work very efficiently, like 2 to 4 times more efficient than even the highest efficiency condensing gas water heater. There's no carbon emission, there's no combustion. You don't have to worry about carbon monoxide poisoning. So there's like a lot of great benefits to a heat pump water heater. And as Randy said too, is like the byproduct of a heat pump water heater is that it blows out cold air. It's like the reverse of a refrigerator. And in California, they're putting the heat pumps inside the garage where they have like plenty of room to breathe. And your garage gets nice and air conditioned in the summertime, which people really like. However, they have a much slower recovery rate than a gas water heater. And so literally a 66 gallon, tankless, or I'm sorry, a 66 or 80 gallon heat pump water heater could take like 7 hours to get fully hot. And when you recirculate hot water through it, basically it diminishes or depletes the heating capacity. And then a homeowner can quickly run out of hot water. And also your efficiency dies too, because these are hybrid systems that have like little electric heating elements in there. And so those typically will turn on too. And then you just lose all of your efficiency gains. So on-demand recirculation is the only type that will work with a heat pump water heater that will maintain the heating capacity, so homeowners won't run out of hot water, and it won't adversely affect the COP, which is the measure of its efficiency. And it's approved for use by most of the major manufacturers, such as Rheem and A.O. Smith. A.O. Smith actually just put out these guidelines for using recirculation with their heat pump water heaters, and they're saying basically they're taking the energy code language and they're putting it on their O&M manuals, basically saying it's got to turn on using a switch or a sensor and then turn off by sensing that either a 10-degree rise or a 102-degree lockout, and then having an automatic timed lockout of 5 minutes. So basically they just, took the energy code and put it right on their stationary there. So anyway, that is the rundown of on-demand recirculation. I hope some of this was informative, and we're happy to answer any questions, or if you guys have any issues in the future, maybe you want to reach out to us to ask about, hey, we got a project, looking to figure out what are kind of some of the best practices or best concepts for hot water distribution. Let us know. We'd be happy to help you out.
Oh, Gabe, I appreciate it again. Very, very informative. And this is one of these things that I know I get this talk a lot when I do presentations for Energy Code and talk about it. A lot of them just they're thinking about light switches and plugs and light fixtures and just power consumptions of that. And then when you start talking water heating, it becomes a different conversation because it's not their first thought in energy consumption and trying to reduce that. But the code, and as you said, and thanks for adding that to the slides, the code is bringing this stuff into it. A lot of it is, I get misunderstandings if they read it and go, oh my gosh, every house has to have a recirc pump. No, they have fit the guidelines and the code language to say, if you're going to use one, this is what we need. Because a lot of times they were ones that were put in, and it was the older ones, like you said, the timers, and they ran for a lot longer
Mm-hmm.
than they should. And so, fixtures like what you guys have fit that great niche for energy code and lowering energy consumptions. The bad part to that is, and I wish there was a way to do this, is, when we build energy models and we do that for new construction homes, I don't know if the models yet are up to the point where we can show the savings on using a system like yours over, not having one or having one that runs for 4 to 12 hours. I wish
Mm-hmm.
we could, because that would make a great trade-off for doing performance modeling as a whole building energy consumption. So I really appreciate all the information you gave
Uh,
us.
yeah, I'd like to, I'm just kind of going through the chat, and I do want to make a clarification. Benjamin, if you're still on the line. So I want to go back to that slide where I talked about the payback. And I want to make a clarification. Yeah, I didn't mean to say that it was a 1 to 2 year payback on the system. What I was saying is that when you compare the on-demand system versus like a conventional recirculation pump, like let's call it a timer-based pump, there's a cost difference between the two. And typically on-demand is a little bit higher price than a timer-based pump. But because of the savings that you get with the on-demand system, the difference in cost is going to be covered within about 1 to 2 years. So I didn't mean to suggest that an on-demand recirculation is going to pay for itself within 1 to 2 years, because no, that's almost nothing has that type of a payback. I don't think there's anything that has that type of a payback. Maybe no, not even an LED light's got that kind of a payback. Um, but yeah, so I just wanted to make that point of clarification.
Yeah, thanks, Gabe, for doing that, because I know Benjamin was asking a lot of questions of that and pointing things out. So thanks for the clarification. There was one other one on here that I think Juliana answered it, but I just wanted to bring it up in case others
Yeah.
didn't see it. But Richard asked the time, the life expectancies of a system like this, and she stated 10 years for that. If you have any
Yeah,
additional.
actually, Actually, I would say it's probably closer to the 15-year mark. In fact, we see on-demand systems that have been out in the field for over 20 years. And it's really, if you think about like how infrequently that pump is running, um, that pump is going to last forever. I mean, not literally last forever, but it's going to be a very long lasting pump. Like I said, we've seen many systems that have been out in the field for over 20 years. Um, I think 10 years is very conservative. I think most likely you could easily get 15 years out of it. Um, but yeah, that's a great question.
Great. Thanks for the clarification on that. And that's kind of what I was thinking too. I mean, these things are pretty hardy, and they use, low power, so it shouldn't be burning them up or running like a consistent pump. So it
No,
shouldn't be that way either.
and again, like I can't overstate like the number one reason why recirculation pumps fail in the field or in a home is because of that airlock issue that I was
Mm.
explaining. You get air in the return line and it gets trapped. Like it's not uncommon to get air in your line because like sometimes work if they're doing work on this on in the city and they could introduce some like air into your plumbing system, but usually it comes out of your fixture, out of your faucet. Like you'll kind of just see the air, cough out of your sink or whatever. But if that air gets into the return line, what happens is it gets trapped because we have check valves in there to prevent backflow. So once you get these little air bubbles coming into the return line, they can no longer find their way out of a fixture, and then, so when the pump is running, it's just spinning, but it's not actually moving water. And that's why pumps fail. So, having that timed lockout, having something that will turn the pump off, is very important to prevent the premature, life of a pump.
That's a great point. And then I like the fact that you talk about something I didn't even know of, like your warranty on your tankless water heaters. And,
Yep.
and like you said, the you have to pay closer attention to the fact that every time that pump kicks on and runs through it, you're counting that clock
It-
down on your warranty. Great point.
Yep, that's right. That's right. Yeah, it usually says 10 years or 12,000 hours of runtime. And those tankless have, they count that runtime. So, yep, very important to control the pump to not just, to a lot to, um, give your pump the longest useful life, but also your water heater.
Well, very good. Well, I don't think we have any more questions in the chat. I thank you so much for you guys being on here and doing this again. We always welcome you guys being here. Always good information. I know it's kind of out of our wheelhouse for when I always talk about energy code stuff, but I even had someone that's on the call today that he's texting me going, you know what? This has opened a whole new level of thinking and energy consumption for me. And he's an energy rater that's active in the field. And it's just you don't think about this water consumption when it comes to energy. And I really appreciate you guys giving us the information today. Thank you.
Well, thank you, Randy. Thank you to Spear for giving us this platform. And thank you all for the great questions. Really good questions. And, here's my cell phone number and my email in case you guys ever have any questions. So thanks again.
Yeah, sorry, I just changed that slide back to this. So I'll just wrap up with what we've got here. Thanks again for being here today, and thanks to Gabe and Juliana being on. We really always appreciate their information. Here's our contact information, our main number, our email, or our website. We're on Blue Sky, LinkedIn, and then, of course, we're also on X. So here's my contact information. Feel free to reach out to us if we have any questions with energy code stuff, or if we can help with anything with AutoHot, or try to mirror something up in the field or work with that. It's always great. And I do think, Gabe, I think you had a good point there. I think Texas is going to see a lot more stuff like heat pump water heaters, as well as more people using recircs, and demand on response for response on demand water heating is going to be big in the next few years. So I appreciate you guys
Yep.
doing this.
No problem.
All right. Thanks, guys. Thanks for being on here. Appreciate it.